Building humanity's first permanently crewed base on the surface of the moon sounds like science fiction, but the plans are already becoming missions, and the hardware is taking shape right now. During the Apollo era, NASA relied on a single, massive launch vehicle to get astronauts to the surface and back. That 1960s playbook worked perfectly for short visits, but a single rocket cannot carry the volume of material needed for a long-term human presence. This chart plots the lunar South Pole's extreme temperatures, swinging from a boiling 130 degrees Fahrenheit in sunlight to a bone-chilling -334 degrees in shadows. Securing these safe zones demands heavy infrastructure. Power grids and habitats must be assembled before astronauts arrive. To solve this massive delivery problem, NASA is executing Phase 1. Instead of relying on one massive launch, they are utilizing a decentralized supply chain made up of more than 20 specialized commercial lunar landers to deliver the equipment iteratively. This strategy is a highly coordinated robotic supply chain designed to conquer the harshest terrain in the solar system piece by piece. The first capability phase in this blueprint is reconnaissance. Texas-based companies like Intuitive Machines and Firefly Aerospace are building the initial scout vehicles to survey the lunar terrain. Firefly is currently preparing its Blue Ghost Mission 2 lander. Its primary objective requires a landing on the far side of the moon to deploy a highly specialized payload known as the Lucy Night Radio Astronomy Telescope. By sitting on the far side, the telescope uses the sheer mass of the moon itself to block all the radio noise emitting from Earth. This creates a pristine quiet zone, allowing the instrument to look deep into the cosmic dark ages without interference. Back on the near side, Intuitive Machines is prepping its third mission, IM-3. It will deliver 5 distinct NASA payloads directly to a site called Reiner Gamma to map complex magnetic anomalies, irregular, localized spikes in the moon's magnetic field. Both of these companies operate on a rapid iteration philosophy. They take hard flight data and engineering lessons from their earlier missions and instantly integrate those fixes into the vehicles sitting on the assembly line today. These early flights are essential reconnaissance sweeps. They map out the hazards and test the landing algorithms so that the ground is completely understood before the heavy construction machinery arrives. To deliver that heavy machinery, the landers themselves have to scale up drastically. This requires the premier environmental testing facilities at NASA's Jet Propulsion Laboratory in California. Here, Voyager Space is putting its Griffin 1 lander through intense ground tests. Unlike the early Scouts, Griffin 1 is classified as an infrastructure-class vehicle, purpose-built to navigate the dangerous, uneven terrain of the South Pole. The capacity of this vehicle is massive. It will simultaneously drop 10 different payloads to the surface, highlighted by the Astrolab Flip rover, the largest commercial payload ever destined for the lunar South Pole. Delivering that much mass means the slightest miscalculation shifts the center of gravity, leading to a crash. Engineers use JPL to measure the exact moment of inertia, how mass is distributed against the axis of rotation of the fully loaded vehicle. Passing these precise ground tests marks a critical transition in the moon base plan. It proves that commercial partners have the capability to safely drop heavy construction equipment right into the most hazardous zones on the moon. The final capability phase demands human-grade technology. Down in Cape Canaveral, Florida, Blue Origin is proving out the core systems for its massive Blue Moon Mark 1 lander. Serial number 1 is designed to test the exact mechanics that will eventually be applied to the crewed Artemis missions, specifically extreme precision landing and the ability to safely offload massive amounts of cargo. Right now, they are checking off major propulsion milestones. They have successfully completed fit checks for the cryogenic liquid oxygen and hydrogen systems and verified the primary BE-7 main engine that will actually fly to the moon. The other half of keeping humans alive is thermal endurance. NASA is teaming up with Northrop Grumman to deliver critical power, avionics, and communication systems originally developed for the Lunar Orbiting Gateway Module. By adapting those existing space-tested systems for the surface, the power grids and communication arrays delivered by early landers will withstand the brutal thermal shock of the South Pole environment. This final pillar provides the extreme survival hardware and heavy propulsion technology required to keep astronauts alive the moment they finally step off the lander. The far-side reconnaissance sweeps, the heavy rover deliveries, and the cryogenic engine tests are all interlocking pieces of a single massive construction project. We have moved completely past the era of the quick visit. The current objective is the active, permanent industrialization of the lunar surface, and the timeline is immediate. These specialized commercial landers are rolling off assembly lines right now, with major launch milestones expected as early as the first quarter of 2027. All of this hardware is tied together and continuously monitored by our deep space communication networks back on Earth. By tracking these upcoming commercial flights, the public is witnessing humanity physically build its first extraterrestrial base, piece by robotic piece, today.